Welcome to our series on learning and teaching maths in English, part of the English as Maths project. Graphs. Key terms. Introduction. What is a function? A function relates an input to an output. What is a function? Names. The most common name of a function is f, but we can have other names like h, g, domain, codomain, range. Domain. What can go into a function? Codomain. What may possibly comes out? Range. What actually comes out? X and Y axis. Axis. The reference line from which distances are measured. The left-right, horizontal, direction is commonly called X. The up-down, vertical, direction is commonly called Y. Where they cross over is the 0 point. We measure everything from there. The x-axis runs horizontally through 0. The y-axis runs vertically through 0. Point. A point is an exact location. It has no size, only position. Points usually have a name, often a letter like A, B, or C. Cartesian coordinates, they are called Cartesian because the idea was developed by the mathematician and philosopher René Descartes, who is also known as Cartesius. He is also famous for saying, "I think, therefore I am." Using Cartesian coordinates, we mark a point on a graph by how far along and how far up it is. The point 12,5 is 12 units along and 5 units up. They are also called rectangular coordinates because it is like we are forming a rectangle. Axis. One of the lines that is used to form a graph. There is the horizontal x-axis and the vertical y-axis in a two-dimensional graph. Direction. As x increases, the point moves further right. When x decreases, the point moves further to the left. As y increases, the point moves further up. When y decreases, the point moves further down. The origin. The point 0, 0 is given the special name the origin and is sometimes given the letter O. Abscissa. The horizontal x value in a pair of coordinates. How far along the point is. Ordinate. The vertical. Y value in a pair of coordinates. How far up or down the point is. Four quadrants. When we include negative values, the x and y axes divide the space up into 4 pieces. Quadrants I, 2, 3, and 4. They are numbered in a counterclockwise direction. Linear equations. A linear equation is an equation for a straight line. Let us look more closely at one example. Example: y equal 2x plus 1 is a linear equation. The graph of y equal 2x plus 1 is a straight line. Different forms. There are many ways of writing linear equations, but they usually have constants like 2 or c, and must have simple variables like x or y. Examples: these are linear equations. Gradient. Slope. A number that indicates the incline or steepness of a line on a graph. Slope equals the rise over the run of a line on a graph. This can also be written as the change in y over the change in x. Slope-intercept form. The most common form is the slope-intercept equation of a straight line. Point-slope form. Another common one is the point-slope form of the equation of a straight line. General form. And there is also the general form of the equation of a straight line as a function. Sometimes a linear equation is written as a function with fx instead of y. The identity function. There is a special linear function called the identity function, and here is its graph. Constant functions. Another special type of linear function is the constant function. It is a horizontal line. No matter what value of x, fx is always equal to some constant value. Graphs of some nonlinear functions. Quadratic function. Square root function. Cubic function. Exponential functions. The form of basis exponential function is where x is a variable and a is a constant, a greater than 0, a equal 1. Logarithmic functions. The form of basis exponential function is where x is a variable and a is a constant, a greater than 0, a equal 1. Specification of quadratic functions. Quadratic function. The form of basic/parent quadratic function is transformations of quadratic function. Vertical translation. Horizontal translation. Reflection. Scatter plot. What is a scatter plot? It is a means to represent data in graphical format. It is used to observe and plot relationships between two numeric variables graphically with the help of dots. The dots in a scatter plot shows the values of individual data points. Example for scatter plot. The local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are their figures for the last 12 days.